Happy Saturday, everybody. It's good to see you again here on Saturday Chat Live. And I'm going to keep saying it wrong for a long time. So very good to see you. If you are in the chat, feel free to drop some questions in there. I'm going to switch over to the chat right now, some comments. So I hope wherever you are in the world here on this Saturday that you're having a good day so far. You're happy and healthy and learning something new, because that's what's important to me. So it's good to see you all. I'm going to try to keep this to around 30 minutes like I always do. Sometimes it goes longer, but we'll try to keep it around 30 minutes if at all possible. So a few reminders about some things that have gone on and are going on. Number one, if you are able to drop in a few dollars into my PayPal tip jar, remember that this month of June, that money is going to be passed on to the Belonging in Statistics fund at UCLA to help students from diverse backgrounds, of course, women in data science and statistics, to kind of generate programming for them. And it's not going to me. So whatever is donated, $5, $10, is going to go right to that and help that cause. And if they hit their goal, the university is going to double it. So if you have a few bucks, drop it in the tip jar for that cause. I really appreciate that. So a few things coming up. I'm working on a few more videos about regression, standard error of the regression, mallows, and then we're going to go on to some other model selection techniques. So I'm working on those as we speak. So limiting factor, of course, is time. So I'll just do the best I can with whatever time I have. Today is actually somewhat exciting in its own way, because here in a couple hours, I'm going to go take my drone pilot test. So I've always loved flying. I always wanted to fly. So I got a drone, and I do photography as well. So I got a drone, and I have to go take that test here in a couple hours. So I've been studying for that, looking at sectional charts here in the US, which are crazy to look at, and doing a lot of studying in my own right for those sorts of things. So I am looking forward to taking that test today here in a couple hours and being able to fly my drone commercially. So if like a neighbor wants me to go to, take a picture of their house from up above, like they're maybe want to do the roof or something else like that, to be able to do it like that, you have to have a license. To even put drone footage on your YouTube channel, it's monetized. You have to have a license. You have to have this license to do that. So I'm going to be doing that later today. I'm looking forward to it so I can get out there and fly my drone and be legal and have everything I need to do that. So that's another thing that's going on in my life I'm really excited about. And hopefully I'll figure out a way to work in some drone footage on my channel, which I've actually thought of some ways I can integrate doing drone stuff into statistics, believe it or not. So that is one of the things I'm doing today. Other than that, everything is pretty much how it is. Larry, what's up, buddy? It's good to see you. Hope you're well over there. So it's good to see Larry, of course. Thank you, Abhinav. Appreciate that. I'm a big fan of yours as well. It may not seem that way. I'm a huge fan of all my viewers. I can't do it in person, obviously, because we're all in different parts of the world, but you won't believe how often I just say a little word under my breath or in my own thoughts, wishing all of those that come to the channel and learn, all the best and can succeed in whatever it is they want to be doing. So I'm a big fan of yours. So good to see you. Yes, I'm good to see you. Sanaz, thank you for stopping by. Let's see. You did have a question. Good question. A lot of people ask these type of questions. So please give us the name of some suitable books for regression, exactly how to analyze formula, about proof of formulas. So if you really want to get into the math and the matrix algebra behind regression, you're going to have to find something a little bit different than a traditional textbook or even a trade book. So there are a few. Actually, two that I would show you are in my car, because I carry them with me everywhere I go, because I go to the coffee shop and work on video stuff. I actually have like a small library in the hatchback of my car. And I'm not joking. I have like 15 pounds of textbooks in the back of my car and like a little cube that I carry around. So a couple of those I can't show you, but one I do can show you is Now this is an older version, but it's a bit more what I consider mathy, and it's the Newbold book. This is an older version. I'm sure there's a newer version, but it tends to be a bit more math heavy. So this is one option if you kind of like a textbook type format, and the author is Newbold, Newbold. It's a bit more mathy. Another one, obviously, is the ISL book. So the Introduction to Statistical Learning is probably the one I would maybe go to first if you really want to get into some of the math behind these concepts. So that's one I would definitely look into. But to be honest, like in my work, I know basically how all the math works and the matrix algebra works. And like in my day job, I've actually written algorithms to generate answers and stuff like that. So I know how it works, but in the general scheme, that's not necessarily what I'm interested in, because my goal is to help students like get through their homework. Like I have a test tomorrow and I need to like know how to do this for the test tomorrow. And I need to get through this class to get my degree and get on with my college education or wherever I'm at, or retraining and go. And 99% of those students aren't really interested in the mathematics behind regression and stuff like that. So it's more practical. So that's what I tend to focus on. But if you are, these books are ones you can look at. Of course, there are numerous online resources you can look at if you want to get into the nitty-gritty of the mathematics behind statistics and other machine learning and similar concepts. There are many of them out there. There are free courses and paid courses that can get you that information if you're really interested. Coursera, of course, has some good ones. So they're definitely out there. Just find one that works for you. So that's how I would characterize that. And on that sort of note, on the mathematics, I do think if you really want to go into more of a programming side or understand like the theoretical background or maybe do an advanced degree in these sorts of things, then having that mathematical background is obviously very important, if not required. But I would say in general, for most students just wanting to get through their uni, or someone who is retraining for a job skill, that's way beyond what they would really need. So all right, good question. So for a regression model, I get from stepwise method, which test should I do to be sure my model is best, or which variable should we get out from the model? So this is very timely. So this is the topic I'm currently working on my YouTube channel, is working through these model selection methods and how the variables are chosen for them. So as I mentioned in those videos, there is no sort of panacea. There is no silver bullet way or method that's going to give you the best model. There's a lot of subjective interpretation in there. You have to have domain knowledge. You need to understand what the variables are, understand the relationship between those variables. So there's a whole lot of art to it as well. But in these model selection methods, in these model building methods, whether it's forward, backward, stepwise, best subsets, and things like that, even within those, there isn't one criteria necessarily to pick the best one. So we tend to look at a variety of measures to determine which model you mathematically, quantitatively, is the best. And when we say the best, what we usually mean by that is the simplest model that explains the most variation in our dependent variable. So we want the one with the fewest number of variables, but variables that make sense, but the fewest number of variables that have, let's say, a high adjusted R-square. Oops, my computer's beeping at me. Sort of an adjusted R-square, standard error of the regression, Mallow's C, which you've probably seen. The AIC is another measure. So you kind of have to look at all of them, and most of the time they will agree, and sometimes they will not. And then you just have to look at the variables that it has chosen and say, well, does that make qualitative sense? Does it make sense in my domain knowledge and understanding? And then look at the ones that are the simplest, but explain the most variation. So I would just understand what adjusted R square are, what adjusted R square is, the standard error of the regression, Mallow's C, the AIC, and then there are actually some other ones too. So to be sure my model is the best, I would say be sure your model is one of the best given that criteria and be able to explain it. So that's what I would say about that. So that's a very good question. A lot of students that are doing these things see these model selection or model building techniques and are like, oh great, this is going to give me my best model. I'm just going to throw some variables in there. It's going to do its wizardry. And all of a sudden I'm going to get the best model spit out the back end of it. And that's all I have to do. Well, if that were the case, then all regression books would be one chapter. And they would just say, okay, dump your variables into this, look at this measure on this output, and there's your best model. But it isn't that simple. You have to do some work leading up to that, and then use your judgment based off what it provides. So it's a comprehensive technique. All right. What other questions anyone has? Feel free to drop them in the chat. I'm happy to answer them to the best of my ability. I will also, while you all are doing that, I will also mention that in my day job, we're very excited. We have a data visualization book coming out with, of course, the online course. And I'm not here to promote it. I'm just kind of pointing it out of other work that I'm doing in my life. So that data visualization book is out now. I believe. I don't have my copy yet. So if you are a professor or a student or something like that and want to have that book kind of as part of your higher education, you can find that or let me know, and I can point you in the right direction. So I'm excited. I'm really excited. We have a great team where I work at Cengage, and it's been a long, long road to get this data viz product out. And of course, I work on the digital side and doing the homework and the Excel activities and some of the video stuff. Not me doing the videos, but I edit the videos and things like that. So it has been a team effort with many obstacles. And of course, COVID has thrown a wrench in a lot of that kind of stuff too. So I'm excited. We're excited to see how that does. It's actually really good to go along with, say, like a business stat book in courseware, or a business analytics. You kind of, under our subscription model, Cengage Unlimited, you can actually have multiple things in there, and it's all one just flat price. So you can combine business stats in data viz, or business analytics in data viz, or you can even do accounting in data viz. So on and so forth. All right. Larry is like, I love data viz. Yes, Larry loves data viz. So make sure you check out Larry's work as well. He does some great work with clients. And if you are in need of any services like that or know anyone that is, please find Larry Lathrop on LinkedIn, Outlytics, and he can help you out. So let's see here. My explanation is excellent. Well, thank you very much. I always say, whatever a teacher I am, I'm actually a learner first. So I spend a lot of time rolling things around in my head to see or to understand how it might come across to a student's mind. So I actually am a learner first and then a teacher second. So but I'm glad that you find it helpful, of course. And Kirk, could I teach Poisson regression? I could. That's definitely a topic that I could put on the list. Yeah, there's no reason why I can't. Just time, but I can definitely put that in the back of my mind. So Larry asked a question. How would you explain adjusted R square to the C-suite? And what Larry means by the C-suite, if you aren't aware, are the chief officers of a company. So chief operating officer, chief human resources, chief technology, the C-suite. So, and this actually goes to a larger point. So we as analysts on some level, whether it's small, analysis or maybe a large scale analysis, the next step is explaining that to the end user or the stakeholder. I know people hate that word, or whoever needs to make decisions based off that information. So how do we explain adjusted R-square to individuals who may not have the statistics and data science background that we have? So in this case, adjusted R-square, the way to explain that, I think, to the C-suite individuals is that in any regression, we're trying to explain as much variance in our dependent variable as possible. But in traditional regression, a characteristic is that the more variables we add, we can only explain more variance. It just keeps getting higher and higher and higher. And that inflates the amount of variance that's actually there. So the adjusted R-square accounts for the number of variables that are in our model. So there is a relative to the number of observations, I should add. So a model with many variables and a low number of observations will be penalized heavily under the adjusted R-square. And of course, I just did a video about this. Thanks for plugging that for me, Larry. So if you go back and watch the previous video I did on adjusted R-square, it walks you through even the math of how adjusted R-square penalizes those models that have low number of observations relative to the number of variables. So adjusted R-square is a way of adjusting or penalizing models that meet that criteria. A low number of observations relative to the number of variables. So it's a way of deflating variance, of deflating it and accounting for that complexity. So that's how I would explain adjusted. It's a long version, but I would just, if I had one sentence how to explain adjusted R-square to the C-suite, is to say it differs from traditional R-square, which is the proportion of variance explained in the dependent variable, by accounting for the number of observations in the data set and the number of variables in the data set. And the difference between the two is sort of a penalty, so we don't inflate the explained variance. So there are probably easier ways I could probably think of in more everyday colloquial terms if I were explaining it to them. And probably in the next 5 or 10 minutes, something will pop into my head that can do that. But that's kind of how I would explain it. Explain it right now. I try to explain things that don't even involve numbers or statistics. It's like, I don't know, maybe adjusted R-square is a recipe that as you add more things, it just tastes worse. So keeping it simple, I don't know. There are ways to do that. All right. I like content questions like that. If I can answer them. Do I have plans to start a series on data science and Python? I do not, for 2 reasons. One, programming and coding is not my forte. It's not my background. And number 2, it's been done so many times in so many ways already. There is so much good content out there already for that I would not be adding in anything to that educational space. So there are numerous, obviously, YouTube channels, YouTube videos that do that. There are courses on Udemy and other free courses that do that. There are thousands and thousands of websites that can help you do that. So I don't think I would add anything to that. What I can add to, and what I do on my YouTube channel, is adding to that fundamental understanding that helps students get through their university or reskilling, whatever it is, and then on. So that's where I'm good. My talents, I think, are at that level of really trying to get students through that initial stage so they can go on to more advanced things. Let's see. I will try to answer this the best I can. I probably need to know more to answer it more completely. But I'm working on an imbalanced data set. I would like to need to balance it. Any insights on the best ways to deal with it, and what are the risks of building a model on an imbalanced data set? So the only way I can think of this question in the context I'm familiar with is having, let's say, a categorical variable that is the dependent variable, something like that. When we create, if we're doing like a machine learning type algorithm, when we're creating our split or our cross-validation sets, whatever else we might want to do, we want to make sure that in both of those, in all those splits, however we do them, that the proportion of observations in our splits matches or is equal to, pretty close to equal to, the proportion of those classes in our overall data set. So I know in some software, they have a little setting that's called stratified that will try to make sure that all the splits and validation sets are all balanced in that way. So I'm not exactly sure if that's sort of what you're referring to. But in that context, the risk associated with having this imbalanced data set, of course, is that the model is going to be biased towards the data it sees, when it's trained. So if the observations are disproportionate in all those splits, then it's going to encounter labels in the dependent variable that it hasn't seen before, or hasn't seen enough, or has seen too much. So I would just say, depending on the context we're talking about here, is just making sure that whatever software you're using, whatever, coding algorithm you are using, whatever it might be, there's probably a setting or a parameter in there that you need to set to make sure that when you split, whether it's just a trained test, traditional trained test, or like cross-validation, that the labels are stratified proportionally across all of those. So that is, just what I would recommend doing. And again, that's highly dependent on the situation you're in, the data you have, the software you're using. There are so many things in there that it's hard to even to know beyond those general guidelines. So, so this question is beyond. It's a bit beyond what I do, but I do appreciate you asking it. So, image classification, so anomalies in greater image. That's a very large image. Using proximity algorithms, can you describe ideas to try? So, unfortunately, I'm not as well versed in image classification. I know how it works, at a general level, but these sorts of nooks and crannies and idiosyncrasies and stuff like that are beyond what I would normally do. So, unfortunately, I can't really offer a whole lot on that particular question. So, again, I know how it works in general, but I can't get into these anomaly finding. Sorry about that. All right. Any plans to do video on factor analysis? Yes, I'd like to do a video on factor analysis. I think it's very important. Reliability analysis, PCA, and so on and so forth. So I am interested in these topics, and I would like to do videos on them. Again, it's just a matter of time. This is also somewhat getting into the area where I think there's already a lot of good content out there already. And I'm not totally convinced or sure how much I would add to what is already out there. But definitely FA, so factor analysis, PCA is very important, of course. And then maybe some of the other ones would be sort of the second tier of topics I might like to do. So yes, on some, maybe on some others, as long as I think I can add something different to the conversation. So. Sorry, my mouth's getting a little bit dry from talking so much, but this kind of crosses over another interest of mine, which is more the analytics side. So I'm all about learning things that actually help people solve problems, whether it's a business or an individual or whatever else it might be. And I know that, so I know FA and PCA and stuff like that are integral parts of a lot of undergraduate, at least here in the US, curriculum. So especially like marketing analytics and stuff like that, they'll talk about customer segmentation and all these other things a lot. And I know, if you're a fan of consumer reports, which I am, I go in and read consumer reports all the time. They will have measures that you can tell are a composite measure of many other individual things, right? So that's a way of dimensionality reduction that you actually see every day. So I'm interested in those topics, and yes, I would like to try to get to some of those. So let's see here. Rodrigo, thank you very much. Love your videos. They got me through public health school. I appreciate that, but you got you through public health school. You did it. I was just there for one part of it to help you along. And I'm sure you have other resources that you look to and watch videos about and stuff like that. And we're just kind of there to help you through that little space, but you did the work. So you got you through. But I'm glad that you found them helpful. Factor analysis. Yes, we love factor analysis. Was it Amy or Amy? Please start a series on machine learning. Your learning techniques are very good. Thank you. I definitely have an interest in doing that. Now, this is one of those areas where there's a whole lot on machine learning, right? Oh my goodness. There's just mountains and mountains and mountains of information on how to learn machine learning and things like that. So, but I do think there are ways that I could approach that and teach that are unique, because the way my brain works, for better or worse. Yeah. So it's definitely something I would like to do on two fronts, because I do think there is some opening there to explain it in a different way that I kind of explain it. And two, I'd like to learn more about it myself. So I know, the basics and a little bit beyond the basics and stuff like that of all the ML, the bulk of the ML stuff that people learn. But I like to learn a bit more about it. And one of the best ways to learn a little bit more about something is to teach it. So I'd be interested in doing that. Again, time. It's just time. So, let's see here. Let's see. Jimmy. Good to see you. Love your videos. Thank you. Good to see you too, my friend. I have one question. When you use the stdev.s in Excel for standard error, n-1 is implied. But for, let's see here, standard error, n is used. Would you explain to use n or n-1 for standard error, please? So these are two questions. It's one question, two things. So the main difference, go back to this one. Sorry for this flipping back and forth. So in Excel, when you see .s after a formula like this, or after a function like this, that means sample. So for this standard deviation .s, it's going to use the n-1 because it's an estimator formula. stdev.p is for population. So it just uses n in the denominator. So I'm not sure if I've ever used the .p, the population one that uses n as the denominator. I've always used the .s. And actually, while I'm talking here, I'm going to open up Excel just to make sure. Let's see here. 1 second. But the basic gist is that .s is the sample, .p is for population, and we must always use the sample, because as n increases, the sample and the population formulas converge. So once the sample size is large enough, so some people say over 30, but I usually say around 100. So once n is around 100, the difference between the two is negligible, if none. So yeah, stdev.p, stdev.s. The difference is one is population, one is sample. I've always used sample. Even if I use the sample one and my n is large, it's basically .p. So it doesn't really make a difference. So that's what the difference between those two is. All right. Like having an Excel open. So hopefully that answered your question, Jimmy. And that is a general thing. Whenever we're estimating parameters, we have to make sure they are unbiased. And that's why we start doing things like n-1, n-2, and stuff like that. Degrees of freedom is one of the hardest concepts to explain in statistics. I hate even trying. But it's about what we're estimating. So, okay, right. So when it comes to outliers, dependent or independent variables, is there any better ways to deal with them other than removing? So yes, there are ways to deal with those. A lot of people I know actually run the analysis twice, one with the outliers in, one with the outliers removed. There's no harm in that. All you got to do is just make sure people understand what you did, So you can just say, there were some outliers that may have affected this analysis. These outliers were removed in this analysis, and this is how it changed. Another way is to transform variables into different scales. So certain non-normal data can be transformed in using log, and that can compress some of the data points. So yeah, so there are transformations. The removals are fine. Those are probably the two most common ways, at least that I'm aware of. So, all right, let's see here. Rishi, seeing your smiling face there on your profile. Like seeing that is awesome. All right. Formula square root. So my phone is going off. Let's not do that. Okay. So, if it's n in the denominator, that is population. So x minus x bar. So of course that is each observation minus the mean squared, and then divide that by n, that'd be population. So, all right. Thank you for the super chat, Arjun. Thank you. That is so kind of you. I appreciate that so much. Let's see here. What tests would be best to conduct on a data set which has graduate semester marks across 8 semesters of each subject? Hypothesis is that X sub of lower semester has some effect on Y sub of higher semester. I'm trying to figure out what all that means. Arjun, tell me what. Drop me a message on LinkedIn if you're there, or on YouTube, or my website. There's a contact form, and I can answer that question a bit better. It's hard. It's very hard to do these type of things in a chat. So I would need to maybe know a bit more about the questions you're trying to have answered, what you're trying to ask. I just need more information. So, one, thank you for the super chat, and two, just contact me with more information. I'll do my best to to try to help you out the best I can. All right, so where are we at here? All right. And yes, I do love super chats. So feel free to drop a super chat in there if you are so inclined. Hello, sir. I'm from Turkey and doing a master's degree in Germany. Your videos are really helpful. Thank you so much. You are very welcome. Burkan, I'm glad to be of some small help to you. And I wish you best in all your studies working on your master's degree in Germany, someplace I hope to get to sometime soon. Jimmy says, thank you. You are very welcome. Says how to get the best fit model regression. So if I'm understanding the question correctly, that's similar to what we talked about earlier when we're trying to choose the best model out of several different models. So the 4 common model building techniques are forward, backward, stepwise, and best subsets. Nowadays, best subsets tends to be the preferred method because computational power has increased substantially since those were first invented. Of course, doing all that by hand would have been crazy back in the day. So best subsets is usually the way people go. And then they use different criteria such as adjusted R-square, standard error of the regression, the Mallows C statistic, the AIC, and their own domain knowledge and common sense to choose the simplest model that explains the most variation in the dependent variable. And sometimes those all agree and sometimes they don't. You just have to like use your judgment. So that's what I would do. That's kind of the video. Those are the set of videos I'm working on right now, actually. Let's see. Much love from India. I love my viewers in India, as many of you know already. I hope to pay it back someday in some form or fashion and come see you all someday. All right. After your videos, can you please suggest any book to follow for statistics? There are many books on statistics. Obviously, it depends on where you want to go after. So, if you want to learn more about just traditional statistics, there are more advanced books, and they're books that go into more advanced topics and usually specialize. So, I don't. Problem is, I didn't think ahead of time, and I have 5 books in my car, which doesn't do me any good sitting here in my basement. So I do have several books that I would recommend that go into more advanced topics. The Cohen book, it's in my car, but I can remember it because it's easy to remember. Cohen, Cohen, is a great stats book that has really good explanations on some of the more detailed nuances of what's going on. I think it's a psychological statistics book, but it doesn't, whether it's a psych stats book or a biology stats book in some ways, or a business stats book, it's stats, 90 whatever % is the same across all of them. So, so the Cohen book is a very good stats book. I'm sure it has a new version out. If you like more advanced things, Wayne Winston and Chris Albright. So Wayne Winston, Chris Albright have more advanced books in statistics. Some of them go into a lot of Excel stuff as well. Disclaimer is I work for the team that actually helps create those books. So I'm not trying to promote them, but that they are more advanced. So Winston and Albright are good authors. You want to look at more advanced type stuff. So it just depends. It really just depends on what you want to do from there. Let's see here. Hello. Nick Subs, thank you for your videos. Whatever stats I know and implement, I learn it from your videos. You are very, you're very welcome. But I was just there to kind of help you teach yourself, and I'm glad that you found them helpful. So keep on learning, my friend. Keep on learning. Let's see. Oops. Am I on Twitter? If not, why? No, I used to be, but I deleted all my social media about 18 months ago, over the past 18 months. So I deleted Facebook, Instagram, Twitter. What else did I have that I deleted? All the social media stuff I deleted. I am no longer on any of the social media. For just my own sort of sanity and mental health, we obviously had a very contentious election in the past 18 months here in the US. I don't like some of the company's business practices and so forth. So what I've just done is just decided to focus on YouTube and LinkedIn. So those are two things that I can manage. Those are two things that are more professional. So I focus on those two, LinkedIn and on YouTube. So I'm not on social media anymore. And honestly, it's been one of the best things I've ever done personally. One of the best things I've ever done. I will never go back. So it made my life so much better. I had one of those apps on my phone that kept track of how often I was unlocking my phone, how long I was on certain, on the social media apps, and actually all apps, but social media apps especially. And it was just grotesque how many times I was opening up my phone and unlocking it, how much time I was spending doom scrolling through Twitter and Facebook and all that other kind of stuff. It was over 2 hours a day. And it doesn't seem like it because it's all done in little chunks, right? I was unlocking my phone like 150 times a day and like spending 2 hours just doom scrolling. I was like, you know what? There's better things in life to do than that crap. So I just deleted it all and it's all gone. I'm never going back. So, of course, I say that, but I will say in some respects, being off social media has made it hard to interact with certain individuals. A lot of people use Facebook groups as an add-on to their courses or whatever else, but I'm not on there anymore. So I can't really take part in that, but it's been worth it. If that's the price I have to pay for my sanity, then it's fine. All right. Diatribe on social media. I could talk forever about that topic probably. After your books, can you please suggest books to follow over stats? I think I talked about that one. There are many books to go after stats. If you want more advanced books, there are several out there, which I mentioned. But really, it's about specializing. Do you want to learn more about regression? There are many books about that. Do you want to go into more analytics? There are more books about that. You want to have more software focus? There are books about that. It just depends on where you want to go after that. Let's see here. Thank you for your efforts. You are very welcome. There's the video on feature selection. Is that coming out? So I'm working on in the space of traditional multiple regression. So I'm not talking like feature selection and some complex. There's some relationship between the two, but choosing which variables to put into a regression model that one makes sense subjectively and two explains the most variance at the lowest cost. It's a simple model. Those are videos I'm doing right now. So the past series of videos I've been doing are all about model building techniques in multiple regression. So go back and watch those if you want to see feature selection, like variable feature selection in the context of multiple regression. Those videos are there now. So, all right. Recommend any Python packages for sentiment analysis? I do not know. I'm only familiar with the standard Python packages that everyone uses for just their basic stuff. One for specifically for sentiment, I do not know. If anyone in the chat does know, please drop it in there, and we can all learn what that might be. I'm pretty sure I've come across it in my reading, but it just, it's just in and out. So my Python experience is kind of pretty boilerplate and standard. So let's see here. Always welcome in India. Yes, I would love to come maybe to Bangalore or somewhere like that and just meet people. Or there's so many places you can go, but let's see here. All right. Yeah, Arjun, I see your comment there again. Just it's much better to contact me one-on-one with those sort of questions, and I'll do my best to answer them. So when I have time to actually devote to it. So, do you mostly use Minitab in real life? Very good question. And the answer is not necessarily. No. I would say most of my work is actually just done in Excel, honestly. Um, if I do use computer program right now, I tend to use JMP, which is a package developed by SAS. It's very powerful. It can a little bit of learning curve to it, but it can do a whole lot of things. I like the output it gives and the customized output you can do. In Excel, there's an add-in I use called XL Stats. So it's XLSTAT that I recommend to everybody. They can get Excel to do things I didn't think it was possible. So if you like working in Excel and you want more advanced things, that's a great add-in. Disclaimer is that the team I work for, my day job, we do have somewhat of a partnership with them, but in a good way, in that students who adopt our textbook and have the courseware that goes with it get Excel Stat for free. So, yeah. And then there are other ones. Sometimes I'll pull out R or Python if I need to do something specific. To me, they're just tools. I pull out like a tool in the garage. I just pull it out, do whatever I got to do, and I use it as a tool. So I am not wedded to any one statistics tool. If I want to do some machine learning type stuff or data mining type stuff, I will pull out a program called Orange. So orange, like the color orange. And it's visual programming, point and click, with nodes. So it's similar to like RapidMiner or something, stuff like that. So I am not beholden to any language or software. I just do the one that gets me what I need the quickest. All right. Let's see here. I would have to go back and look at my notes. So in logistic regression, attain a CI of the odds ratio. Do we exponentiate the values of the predictive variable CI? I would have to go back and look at all my notes on that. Here's the thing. Anyone who knows anything, whether it's coding or stats or whatever else, all this information isn't in the front of our heads all time. We have to go back and stack overflow it mentally. So tell you what, Sanzar, if you send me that in a message, either on LinkedIn, YouTube, like messaging or something like that, or my website, and I'll see if I can find the answer to that. So, all right. Let's see here. All right, where are we at time-wise? 48 minutes. Okay, got to keep an eye on the time. In stocks, there's the so-called beta. So to evaluate the volatility, start over. My brain goes faster than my mouth. So in stocks, there is the so-called beta to evaluate the volatility stock in relation to a benchmark, such as the S&P 500. This beta is just a linear coefficient of a linear regression. Could you explain how to use p-values and correlation in order to evaluate the beta? So the betas are always published for an equity stock. So those are easy to find. Now, what they usually don't publish are any confidence intervals around that sort of the slope, we would say, of that regression. So sometimes you might find that information in the prospectus of a fund or in a quarterly report or something like that. They might publish that detailed information. Sometimes you might just have to go do it manually. So it might just be downloading the closing price, whatever you want to use, closing price of the S&P 500 for a date range, download the closing price of a stock for a date range. If you want to, you can standardize them, might make it a bit easier. And then just find the correlation between sort of the two. And of course, when you do that manually, you will get all the information about confidence intervals and p-values and so on and so forth. And then how do you use them? Well, of course, if the p-value is insignificant, then there's no real linear relationship there because the confidence interval would include 0. So on this one, you might just have to do it the old-fashioned way and just download the data, run your regression, which is, in this, if it's 1-to-1, it's just basically a correlation, and then see what the actual p-values and the coefficient is, which would actually be a fun thing to do. I might actually make a video doing that. So thank you, Edgar, for that idea. All right, a few more minutes. Plus, in like an hour, I have to go leave to take my drone test, so I can't go too long. I'll let you know how that goes. So for standard error calculation for the same set of data, you get a slightly different numbers from Excel in TI-84 plus. Any clue? I don't, off the top of my head, I don't know why that might get a slightly different numbers. I'd have to maybe try it out and see, but like sometimes you don't know what they're doing behind the scenes in these functions. So a common one is how many digits, are they, is it just completely floating point, or is like the TI limiting the number of digits it uses in its intermediate calculations? I don't know. So I will say, if the difference between the two is in like the 6th digit, that's probably not meaningful. If the differences are closer to the decimal point, then that could be meaningful. So it just depends on where the difference is and by what magnitude. But off the top of my head, I don't know. And this is true that you can get slightly different numbers for the same calculation depending on the software or the device or whatever you're using, but they should be pretty darn close out to several digits. So let's see here. Hard to know. If one of the 4 assumptions of linear regression is violated, is it better to transform, normalize the attribute values, or select another regression algorithm? It's hard to know without, a specific. Every situation is different. Some variables can be transformed. Some should not be transformed. It's hard to know. Some people go ahead and do the regression and just note that this assumption was violated, and therefore the output or the conclusions should be seen in that context. So it just depends. All right. A few more minutes. No one will do a better job explaining machine learning than you. 100-page machine learning book you recommend is full of jargon and obscure mathematical notation. So yes, that can be a good thing or a bad thing. So it's good for people who don't want to have some of that basic mathematical background to know how things are working, but it is also good at explaining some basic concepts. So that's why it's popular, and like with all books or learning materials, I take the bits from them that I find useful for my needs, and the other parts that I don't need, I don't think is bad. I just don't need them for my purposes. So, so I think that book is very good. It's very popular, of course, and there are others. The one book I do recommend, do I have it down here? Oh, I do. Ha ha. Ha ha. This is the book I recommend. If you are new, if you like the way and I'm not plugging this or whatever, there's no like affiliate link. If you like the way I teach and explain things and you want to learn more about machine learning, this is the book. So this is it. I've read this book so many times, I think I have it memorized. I just love reading it. And Oliver is a great person too. I talked to him on LinkedIn. Really, really cool dude. So I recommend that book. All right. Where are we at here? Try to catch up to your comments. Thank you for your patient explanation. You are very welcome. Thank you for putting in the hard work. How should one approach to learn Excel from beginning to advanced and pro? What functionality of Excel one should have hands-on? There are many, many resources to learn Excel. Many of them are free. I think Microsoft has their own training that you can go find. Can I find it here real fast? Microsoft, let's see. Excel training. Yeah, Microsoft 365 training. So, see if I can put this in the chat. Microsoft has training here. So I can put that there. So I put that in the YouTube chat. Microsoft has their own training. It's just support.microsoft.com/training. And you can find all kinds of free training there specific to them. So that's a good place. Obviously, there are free, many, many free videos on YouTube. Udemy is a good place if you want more advanced stuff with like files you can practice on and, you know, tests and stuff that kind of test your knowledge as you go along. And they're usually not that expensive. So, all right. So, yeah. And there are books, of course. So just pick the one that you like to learn. Linear regression, playlist on that, I do. Logistic regression, playlist, I do. Decision trees, SVM, NNs, KNN. I do not have videos on those just simply because of time, of course. And to make videos on those other topics, I would need to do some pre-work videos, like at the very beginning, just like at the very beginning. So what is supervised and unsupervised learning? What are the differences between dependent variables that are quantitative and classifiers and all that kind of stuff? So I would want to set it up properly, you know, to do videos like that. I would love to make videos like that, but time is not enough. All right. Good luck on your drone license test. Thank you very much. Here in the US, it's called Part 107. If you want to fly your drone commercially for any sort of benefit, you have to take this 2-hour test, and it's not easy. So I've been studying for it the past week. All right. All right. Is the T statistic, the T statistic for intercept relevant in regression? Sometimes yes, sometimes no. Depends on the problem. So I would say most of the times, usually it's not, but sometimes it can be. And of course, if 0 is relevant in your data, then it's more likely to be relevant, right? And sometimes you can fix the intercept at 0 and force the regression line to sort of, you know, tilt from that point. So this is a domain knowledge question, and it's specific to the problem being investigated. But having it, there's nothing wrong with having it. So it just depends on the question. All right. Yeah, the math and stuff behind this is everyone has their camp, you know. The beta, you mean depends on the p-values and correlation, same beta. Useless. Well, the thing is, the published betas in financial websites and documents and stuff like that has already been calculated for you. If the beta is very low, then they may not march in lockstep. So when I see a beta number on a stock or a fund, you know, something like that, I just take their word for it that the interval is meaningful, if that makes sense. So it's hard to know. It's really hard to know. All right. We're actually at an hour here. So what's left? You are very welcome. Oh, I can put this up as me. So I just realized I can put up my own comment on the screen. Duh. So here is Well, I think of this earlier. This is the URL to the Microsoft training. So obviously Excel is on there, but all the other, Office applications and stuff are on there too. So, all right. Let's see. You're welcome. Yes, I think this is a good point. So even though I consider myself an advanced learner, I'm an ML engineer at Big Four Tech, I still watch your videos as a refresher. Strongly recommend your content to all my students. Yes, absolutely. And whether it's my content or someone else's content, it's really good to go back and just make sure that foundation is solid, right? On understanding, foundation on learning. Because I think we just need to know what we're doing in these models. I just have a fear. I'm not saying this is you at all, but as a society, we're building these models without really appreciating or understanding what's going into them, the effects of them coming out, if our assumptions are correct. I believe domain knowledge and just like history and current event knowledge, reading the news and reading biographies, I think all of that is just as important as typing in code. I think it's just as important as typing in code, if not more important, So, for example, what's going to tell me more about finance, a financial analysis book, or something like this? If I want to understand the housing crisis, I'm not going to go through a bunch of spreadsheets. I read this to understand what happened. So you got to do both, I think. Right? Okay, I'm going to wrap this up here in a few minutes. Is t-value really important, or only r-squared and p-value both are good enough? All of it's important. So our t-statistic is what we look at for our coefficients to make sure that they are actually important in the model. R-squared tells us our explained variance. Of course, if we're using more than one variable, we should use the adjusted r-square to accommodate the additional variable so we don't inflate our variance. Of course, p-value is just sort of the corollary of the t-value. So depending on how complex the model is, all of these are important, and you just have to know how to interpret them. And when you explain it to someone else, how to translate those into actual explanations. But they're all important. Absolutely. Oh, goodness. What do I think about data sport analytics? How's the future? Oh, my gosh. This could be a whole show on its own. Here's what I want to say. I'm going to try to keep this short because I get mad. So, sports analytics. Obviously, I understand why it exists, but for me, sports analytics has largely ruined my enjoyment of sports, to be honest, on two fronts. One, every sports telecast I watch on television looks like a Tableau dashboard, and I can't actually watch the game or the match or the race or whatever else. So just as a viewer on television or wherever else, it has ruined my experience of just enjoying it visually. And two, obviously sports teams collect all the data and analyze it to improve their performance, which is another way of saying making more money in a lot of respects, which is exactly what they're supposed to be doing. But the problem for me, this is just my personal view. This is my personal view, is that the more data points that are collected and get fed into these models and algorithms and so forth, a couple of things happen. Number one, it changes how the game is played. The most famous example is the three-point line in the NBA. If you look at shot charts in the 90s versus shot charts now it's all three-pointers and dunks. Whereas before, there was a more mid-range game, but the three-point line has changed that. And the analytics are the things that told coaches and teams that. It's more average points per shot. So that's what they do. So it changed the way the game is played. It changes the way it's experienced. It changes the way the teams are built and they practice. Because in the end, it is designed to optimize an algorithm. So everyone's trying to optimize the algorithm to score more points or race faster or score more goals, whatever else it might be. But it also has the element of taking the inherent, unexpected joy of the randomness out of it. When everything is measured, when everything has a data point put on it, and it's fed into these complex models, statistically what's happening is they're squeezing the error term literally down as much possible. Well, for me in sports, the error term is like the thing I don't expect to happen, or the randomness that I don't expect to happen, you know. But teams and coaches and general managers start playing the algorithm and not playing the game. So a lot of the randomness and the surprise factors are taken out of it, because for every situation in a sport, almost every situation in the sport, there is now an optimized algorithm that says what should be done in that instance. So, like I said, this is something I just really think about a lot, and I think that extends into other areas of life too. The more we measure something, it gets fed into a model that is then optimized as much as possible, squeezes the error out of it, and then everything becomes, behave in this way to optimize this model's prediction. And I just think we got to really think about what that does to our daily life, whether it's sports or anything else that we do. That's why I try to live a largely analog life as much as possible. So anyway, I could talk a whole lot about that, but I think we just need to keep all these things in mind. And those are all my personal views, of course. So, all right. I suggest coming to the Black Swan. That is on my book list, so I will definitely move that up my book list. I love ideas like that. Of course, the more I read, the more I realize that Black Swan events aren't necessarily that Black Swan. They're just things that people ignored as possibilities. Yeah, so sports data analytics, yeah, DeepMind is hacking soccer as we speak. Absolutely. When they put, when you can track the position of every player at any given moment relative to the ball, you can feed in all the players' histories and stats and predilections of how they behave and move and stuff. You can feed all this stuff into this model, and it just becomes a video game. You're just doing what the model optimizes it to do, So I don't know. I understand it's rational. I understand why people do it. I get it, yeah. All right, so I can get off that topic. All right. Restudying matrices and vertices, absolutely. Matrix algebra, linear algebra is very important. If you want to understand the math, it's fundamental. If you want to understand the math behind some of this stuff, so absolutely. I'll put this up for everybody. Recommend Gilbert Strang's linear algebra textbook and his videos from MIT on YouTube. So if anyone's looking for some linear algebra, I actually like linear algebra. I tutored it for many years at Indiana University. So check those out. Yes, the learning happens in the exercises. So do as many exercises as possible. And look, that's true. The learning, most of the learning is in the doing. So I wish YouTube actually for educational channels actually had the ability to do little pop-up quizzes for people if they want to do them, or they could skip them. If they can pop up an ad in the middle of a video, you would think that for educational content, they could pop up a little quiz for someone to do. like a little multiple choice quiz just to check learning. It can't be that hard, you know? Um, but yeah, the learning is in the doing in many of these things. So that's why Udemy, for the most part, is a good learning resource, because a lot of the good instructors on Udemy actually have things you can download and follow along, code examples, stuff like that. That's why on most of my videos I have the data set. You can go to my website and download and follow along if you want, so you can actually do it along with me. But yeah, the learning is in the doing, and then in the reflecting as well. So learning how to do this drone test I'm about to do in like an hour. Luckily, it's down the street. It was in the doing. I could read all this stuff all I want, but then I had to go in. I've done like 5 or 6 practice tests in preparation for it. The learning is in the doing. Actually, reading the chart on the reading the sectional chart and reading what's called the METAR, which is like the weather and the visibility and stuff like that at a given airport. So you just have to like do it. Just got to do it. And it won't always be right. So, all right. So we are at well over an hour here. I never do plan on going this long, but we do go this long, and that's fine. I got time. It's all good. Yeah. So I'm glad you all stopped by. I'm gonna go ahead and wrap this up, and I will see you again next week, but not the week after. So that's July 4th weekend here. I'm gonna take that weekend off, try to relax a little bit, do a little R&R, enjoy the sun. But I will be here next week, trying to line up some guests for future shows as well. But these little shows with just me actually seem to go very well, so I'm happy about that. But yeah, check out the channel over the next few weeks for some more videos. I'm trying to work on those the best I can with the time I have. So I'm going to continue multiple regression for a little while, and then we'll see where that goes. Time series is a highly requested topic that I might get into. So, YouTube is free because I kind of have to do it in my spare time, and that is just the pace of free content. I can't spend all my time doing content I can't earn a living doing. So I do the best I can. But all right, everybody, I'm going to wrap this up. But thank you for stopping by, and I wish you all a very safe and happy and healthy rest of your Saturday, wherever you happen to be in the world. So take care, and bye-bye.